we're looking at 8.5, question number 5. This, we're working a little bit backwards. We don't know what n is. We're trying to find n. So what we're going to do is we're going to use this formula where you have to know the critical z value. You have to know the proportion and 1 minus the proportion and the margin of error. So if you square your z value, multiply it times the proportion times 1 minus the proportion and divide it by the margin of error squared, you will get the sample size. So we are going to do that. For the first one, we know first of all, if you look at your table, let me make sure everyone knows how to do that. This is found in your proctor exam formula sheet. But if you need to know the 90% confidence interval, we're going to be using 1.645. That is very important that you know your z value. So for question number A, we know our z value is 1.645. So we're using the formula I just showed you. If we square our z value, 1.645 squared, and then our proportion is 0.20, and 1 minus our proportion is 0.80, and we divide that by our margin of error, which is 0.07 squared. If we put that in our calculator, 1.645 squared times 0.20 times 0.80, and then divide that by 0.07 squared, you will get, I believe, you're going to round up, so you're going to round up and get 88. Okay, for the next one, your proportion would change. For problem B, you would change these numbers here. So instead of it being 0.20, we have 0.30, and then 1 minus 0.30 would be 0.70. And if you put that in your calculator, it will round up to, let's see, 116. And then for the last one, you would do 0.40 and 0.60 here. So 0.40 and 0.60 here, and that would give you round up. Regardless if it's 132.1, it still wants you to round up to the next integer. Okay, so moving on to the next question. So you're just using the formula and you're working backwards. Give it just a second. On question number 6, it wants you to determine the sample size. First of all, 90% confidence interval. If you look on your table that we looked at in the previous problem, for a 90% confidence interval, I believe your value is 1.645, and we're using our formula where we work backwards. So 1.645 squared, the proportion, actually we're not using proportion here, we're using the standard deviation. So this other formula for n is the z value squared times the standard deviation squared divided by the margin of error squared, which is 0.5 squared. So if you work that out, you will get 11. It will round up to 11 for the sample size. Okay, on question number 7, we have a confidence interval of 99%. So the z value is 2.575 squared, and the standard deviation is 7,000 squared, and the margin of error is 3,200 squared. And so once you calculate that, you will round it up to 32. 2.575 squared times 7,000 squared divided by 3,200 squared is 31.7, but you're going to round it to the nearest integer on all of these. Okay, so for the next problem, for question number 8. On this problem, it's a 90% confidence interval, which is a z-value of 1.645 squared. I'm still using the table I showed you. Let's see, the standard deviation is 0.05, so 0.05 squared, and the margin of error is 0.006 squared. So once you plug that into your calculator, you will round up to 188. Okay, on question 9, this one I had a little trouble with because it's asking for a 94% confidence interval. I don't know. I looked it up on my phone for this one because I don't have that in the table. So the way that I did it was I searched Z critical value calculator, and let's see. And then the probability value here. Now this is something you have to be careful about, okay? First of all, you want a confidence interval of 0.94. So before you figure out the area, just remember 0.94 includes from here to here. So you have 3% over here, and because it's a two-tail, and you have 3% over here. Now, we want the critical value of this point right here on back. So if our confidence interval is 0.94, we want the probability of here back. So that up to this point is 0.94 plus the 0.03, which equals 0.97 is the area that we want. So we would plug in 0.97 here. And you hit calculate, and your critical value would be 1.8808. So if it's not on the table, that is how you can work it. So now we can use our formula. N equals, let me go back to what I was using, 1.8808 squared times 0.70 times 0.30. And the way I got 0.70 is I did the 35 here out of the 50 voters. That's how I got 0.70, and 1 minus 0.70 would be 0.30, and the margin of error is 0.05 squared. So when you do all of that, I believe you get, let's do that real quick and see what we get. 1.8808 squared times 0.70 times 0.30 divided by 0.05 squared, you would get 298. You get 297.1, but it says round up. So you get 298 minus the 50 voters you've already sampled means we need 248 more. Okay, looking at question number 10. This one is a 99% confidence interval, and that's easy because we know the z-value is 2.575. So this one will be a lot easier. So 2.575, you're confident, square it because we're working backwards here. We don't know the population proportion, so we're going to do 50-50 when we don't know. So 0.50 times 0.50. You can read about that in the example. And then the margin of error is 0.05 squared. The key here is without any knowledge of their population proportion. So we're going to assume a population of 50-50. Now, once you do all of that, you will get a number and round up to 664. If you have a TI-84 or TI-83, it's going to be a lot easier to put all these calculations in. So moving on to the last question, question number 11. You can see here the 90% confidence interval. So if you look that up on your chart, it is 1.64, or your table, 1.645 squared. It looks like 28 out of 50. So 28 out of 50 would be 0.56, and 1 minus 0.56 would be 0.44. So these three things, 1.645 squared times 0.56 times 0.44 divided by the margin of error, which is 0.05 squared. And I think when you calculate this, you end up getting 267, but we've already sampled 50, so we need 217 more.